Here's something that might shock you. Even the most advanced electric SUVs on the market today are failing to deliver what their manufacturers promise. And this isn't just a minor discrepancy we're talking about. When CarWow decided to push 5 premium electric SUVs to their absolute limits, driving each one until the battery completely died, the results revealed a troubling reality that every potential EV buyer should know about. The gap between what these vehicles claim they can do and what they actually achieve in real-world conditions is far more significant than most people realize. Now, before we dive into the controversial findings, let me be clear about something. Range anxiety isn't really the monster under the bed that it used to be. The only electric vehicle that still makes me genuinely concerned about getting stranded is the Volkswagen ID.Buzz. Beyond that specific case, most modern EVs have theoretically conquered the range problem, particularly for drivers who have reliable access to fast-charging infrastructure in their area. But here's where it gets controversial. That confidence might be built on shaky foundations. The team at CarWow has developed what I'd argue is a healthy skepticism toward the range figures that automakers love to advertise. These official numbers typically come from the Worldwide Harmonized Light Vehicles Test Procedure, commonly known as WLTP, which tends to be quite generous in its assessments. That's precisely why CarWow has made it their mission to subject numerous electric vehicles to grueling real-world tests, and their latest investigation features 5 heavy-hitting SUVs that represent some of the most advanced EV technology available today. In their comprehensive examination, host Matt Watson put the Audi Q6 e-tron, BMW iX, Genesis GV70, Kia EV9, and Polestar 3 through an exhaustive evaluation process. Each vehicle was driven continuously until its battery reached complete depletion, providing genuine real-world range data that buyers can actually rely on. What they discovered was simultaneously fascinating and concerning, especially for anyone who gets excited about EV technology like I do. The most predictable finding was that vehicles with larger battery packs naturally achieved greater overall range. No surprises there. But here's the part most people miss. Despite these SUVs representing different manufacturers, price points, and engineering approaches, their real-world efficiency ratings turned out to be remarkably similar. This suggests that we've reached a certain plateau in EV efficiency technology, which raises important questions about where future improvements will come from. Let me break down exactly what CarWow measured, because understanding their methodology is crucial for interpreting these results properly. Their approach was refreshingly straightforward. Drive each vehicle until it stops, then record that distance as the true real-world range. Using this data, they calculated 2 critical metrics that every EV shopper should understand. The first measurement is overall efficiency, which functions similarly to the miles per gallon rating we use for gasoline vehicles. This figure represents how many miles an electric vehicle can travel using just 1 kilowatt-hour of energy from its battery pack. Higher numbers indicate better efficiency, and this metric serves as an excellent indicator of how well-engineered an EV platform truly is. It reflects everything from powertrain optimization to aerodynamic design and the efficiency of all the various systems that draw power from the vehicle's battery. The second measurement is where things get really interesting and potentially controversial. This is the percentage difference between what the vehicle actually achieved in real-world driving conditions versus what the WLTP testing cycle claimed it should achieve. And this is where some uncomfortable truths start to emerge. Here's how each vehicle performed in CarWow's rigorous testing. The Genesis GV70, equipped with an 80 kilowatt-hour battery pack, managed to travel 279 miles before running out of power. This translated to an efficiency of 3.49 miles per kilowatt-hour, while its WLTP rating suggested it should achieve 298 miles. The Genesis actually delivered an impressive 94% of that advertised range, making it the most accurate performer in the test. The Kia EV9, powered by a substantial 99.8 kilowatt-hour battery, achieved 329 miles of real-world range with an efficiency of 3.30 miles per kilowatt-hour. Its WLTP rating promised 360 miles, meaning it delivered 91% of its advertised capability. The Polestar 3 emerged as the overall range champion, traveling a remarkable 390 miles on its 107 kilowatt-hour battery pack, while achieving the highest efficiency at 3.64 miles per kilowatt-hour. However, against its ambitious WLTP rating of 439 miles, it achieved 89% of the advertised range. The BMW iX xDrive 60, despite having the largest battery at 109.1 kilowatt-hour, managed 366 miles of range with 3.35 miles per kilowatt-hour efficiency. Compared to its WLTP rating of 436 miles, it delivered 84% of the promised range. Finally, the Audi Q6 e-tron Quattro with its 94.9 kilowatt-hour battery achieved 325 miles of range and 3.42 miles per kilowatt-hour efficiency. Against its WLTP rating of 388 miles, it delivered 84% of the advertised range. Now, determining a winner. From these results depends entirely on what you value most as a consumer. If absolute real-world range is your primary concern, the Polestar 3 clearly dominates with its 390-mile achievement. If you're looking for the most efficient use of electricity, the Polestar 3 wins again with its 3.64 miles per kilowatt-hour rating. But if accuracy and honest advertising matter most to you, the Genesis GV70 takes the crown by coming closest to delivering what it actually promises. But here's where the story gets even more intriguing, and this is information that might make some manufacturers uncomfortable. CarWow has been conducting these tests consistently, building an extensive database that now includes results from multiple test sessions dating back to December 2024. When we examine this broader dataset, which includes 9 additional EVs from manufacturers like Audi, Ford, Kia, Lotus, Polestar, Porsche, and Tesla, some eye-opening patterns emerge. The Tesla Model Y maintains its position as the efficiency king, achieving an outstanding 3.92 miles per kilowatt. However, and this might surprise Tesla fans, it performed nearly the worst when comparing real-world range to advertised WLTP figures. Even more concerning for Tesla is that this poor performance isn't limited to European testing standards. It also ranks as the worst performer when compared to EPA-rated range among all vehicles tested. Looking at the complete results across all tested vehicles, some clear winners and losers emerge. The Genesis GV70 leads in accuracy at 94% of advertised range, followed by the Kia EV9 at 91%. The Polestar 4 achieved 90% of its advertised range with 333 miles of real-world driving and 3.54 miles per kilowatt-hour efficiency. On the efficiency front, after Tesla's Model Y, the Polestar 3 ranks second at 3.64 miles per kilowatt-hour, followed by the Ford Explorer EV, Polestar 4, and Kia EV6. These efficiency ratings are arguably the most important metric for comparing vehicles since they directly relate observed real-world range to usable battery capacity. However, the Polestar 3 remains the undisputed range champion, traveling 390 miles before complete battery depletion. This represents more than a 6% advantage over its nearest competitor, the BMW iX xDrive 60, and more than double the distance achieved by the disappointing Lotus Emea R, which currently holds the dubious honor of being CarWow's most underwhelming range performer. And this is the part most people miss when shopping for EVs. The methods that automakers use to estimate vehicle range are fundamentally flawed. This isn't just my opinion. It's supported by data from organizations like SAE International, which published research in 2023 demonstrating that electric vehicles fail to meet EPA estimates more frequently than traditional gasoline-powered vehicles. But here's where I want to get controversial and ask you a direct question. Is this acceptable? Should we continue to tolerate a situation where the vehicles we're spending $50,000, $60,000, or even $70,000 on consistently fail to deliver what their manufacturers promise? And more importantly, Are we as consumers partially responsible for enabling this by not demanding better accuracy in range estimation? I'd argue that this represents more than just a technical problem. It's an issue of consumer trust and transparency. When someone is considering making the switch from gasoline to electric, accurate range information isn't just helpful. It's absolutely critical for making an informed decision. The current system, where vehicles routinely underperform their advertised capabilities by 15 to 20% or more, undermines confidence in the entire electric vehicle industry. The testing methodology employed by CarWow provides invaluable real-world data that every potential EV buyer should consider before making a purchase decision. Their comprehensive approach goes far beyond simple range comparisons, examining efficiency, accuracy, and practical usability in ways that laboratory testing simply cannot replicate. For anyone currently shopping for an electric SUV, especially with the impending end of the federal EV tax credit in the United States, these results provide crucial insights that could save both money and future frustration. The differences between advertised and actual performance are significant enough to potentially influence charging planning, daily usability, and long-term satisfaction with your electric vehicle choice. So here's my challenge to you. Do you think automakers should be held to higher standards for range accuracy? Should there be consequences when vehicles consistently underperform their advertised capabilities? And as consumers, what can we do to demand better transparency in EV range estimation? I'd love to hear your thoughts on whether you think this level of discrepancy is acceptable, or if it's time for the industry to adopt more realistic testing standards that reflect actual driving conditions rather than optimized laboratory scenarios.